continuous variable probability density function and cumulative distribution function. Welcome to second episode of the course. It's fully self-contained, so even if you didn't watch the first episode, you will understand this. But if you want to watch the first episode of Random Variables Introduction to Probability, link below the video. My channel is about AI research, so I will just mention that this is used in large language models, reinforcement learning, diffusion, flow matching, everywhere. Let's take a height of a person as an example. This can be any continuous number. It doesn't have to be exactly a whole number like 175. This can be 0.1, 0.11, or very long number. So our random variable age that represents height of a person. Now it's gonna have different value for different people. But let's take one instance. One value, possible value. It can be this number, or we can put one decimal, or we can put two decimals, or we can put infinitely many decimals. And these are all different numbers. So this number is a bit bigger than this number. This number is a bit bigger than this number, etc. And this goes to infinity. And this infinity is the problem. Let me ask you, what is the probability of a person having height exactly 175.000 to infinity centimeters? It's 0. And why is it 0? Well, we already established that there is infinite possible heights. And so if you have infinite possible things, what is the probability that it will hit like this thing amongst infinite possible things? And first of all, practically, it's 0. And mathematically, we can imagine an infinite wall and throwing a dart to infinite wall. And what's the probability that dart hits exactly like 1, 1 on the coordinate system? Well, if it hits 1, 1, that's a successful outcome divided by number of possible outcomes, which is infinity. So it's 0 or tends towards 0, however you want to say. So for continuous random variables, like this one, we can no longer look at probability of a single event or single outcome. We need to look at the range of outcomes. So what is the probability that this variable falls within a certain range is what we're gonna look at. For example, what's the probability that the person's height is between 170 and 180 centimeters? And now all of a sudden there is an answer to this. And since we no longer can assign probabilities to specific points or outcomes, we need a new tool that's probability density function, or PDF. This is what it looks like. And then if you want to find the probability of a variable being between points A and B, you just calculate the area under this curve, which is very easy to do. And that's how you get probability that the random variable x is between points A and B. So the total area under the whole curve must be equal to 1, which represents 100% probability. And the probability that event x falls between 2 points A and B is the area under the curve between those 2 points, A and B, that I just explained. And we have a very famous probability distribution, which is this normal curve or bell curve or Gaussian curve. And many natural events fall and happen in this shape. Now some might be a bit more, for some events the curve might be more stretched or more peaky. Here we have 3 bell curves with different mean and standard deviation. So mean is the center point of this peak, and standard deviation shows how spread out the curve is, how stretched the curve is. And mean is just another name for expected value that we talked about in the previous video. If you click the link in the description, you will see the entire course of these videos. Next, very important, very useful function, cumulative distribution function, denoted as f of x. So it's a probability that a random variable x will take a value less than or equal to some number x. So, again, the probability of value of the random variable x being equal or less than some known value x. This works for both discrete and continuous variables. So let's look at the example of the dice again. These are discrete states, so it can be either 1, 2, 3, 4, 5, or 6, depending on how the dice rolls. Those could be outcomes. It's not continuous where it can be 5.36. No, it's just these discrete values. And probability for each of them happening is 1 over 6. Let's calculate cumulative distribution function for 1. So the probability of it being 1, okay? So it's just, in this case, 1 over 6. Let's see for 2. So the probability of the outcome being 2 or less, which is actually 1 or 2. So it's a probability of outcome being 1 plus probability of the outcome being 2. So now it's 2 over 6, or 1/3, or 33.33%. We can put in any value, not just these possible outcomes. So we can say 3.5. So the probability of the outcome being 3.5 or less, well, it can only be 1, 2, or 3 in that case. So the probability, if we add all three of those probabilities, we will get 3 over 6. And in this case, if we put 6, that includes all of the possible outcomes, so that's 100%. So that's gonna be 1, which makes sense. We can also say for 10, outside of the range, it's still 1 because it will always be less than 10. That will be it for this video. You can check this full course link below in the description to learn about AI research and how probability is used in AI research. Every top AI researcher masters this.